The Peace Chapel is somewhat of a hidden gem in Huntington. Hopefully many of you know about it. It was designed by world-renowned architect Maya Lin, who also won numerous awards and designed the Vietnam Veterans Memorial Wall in Washington, D.C. The Peace Chapel is located just off Warm Springs Road and has numerous trails surrounding it, connecting it to another Huntington landmark, Flagpole Hill. My family and I have been up there a few times during quarantine to get some exercise while practicing social distancing, and it's stunningly beautiful early in the spring when things are growing and ready to bloom. Two of the best ways to protect yourself from the coronavirus are to abide by the safety guidelines such as social distancing, but more importantly, to stay healthy and fit so your body and immune system can fight off diseases, including COVID-19 and many others. So I highly recommend hiking these trails for a variety of benefits. It's well worth it. And of course, math is everywhere. And while we were hiking and got close to Flagpole Hill, I saw this. A giant cylinder whose capacity or volume, and many of the contents that fill that volume, are extremely important to the people of Huntington because it's their water supply. So I had to take a picture and share it with you, knowing that our next lesson dealt with the volume of cylinders, and I just love the coincidence of the world, almost like it's meant to be. We are actually going to be talking about the volume of two different three-dimensional objects. One is the cylinder, of course, and then also the cone. Before we get started, I want to remind you, when we've been looking at volume, we've been looking at volume equals capital B times H, where capital B is the area of the base. And this is for prisms. However, a cylinder kind of acts the same way as a prism, where the base happens to be a circle. All right, and we know that the area of a circle is pi r squared, so it's no surprise that we see that in the formula for the volume of a cylinder. It's capital B ends up being pi r squared, and then multiplied by the height. Now, that being said, you will notice that the volume is pi r squared h for a cylinder, but then for a cone, the only thing we do is we divide it by 3, which actually means that we can fit 3 cones into a cylinder if they have the same base, so the circle is the same size, and they have the same height. To demonstrate this, I found this cool video off of moomoomath.com, which is a really neat website, and they show the cylinder is the same height as the cone, and it has the same size base, and they're going to take the cone and they're going to fill it with water 3 times and pour it into this cylinder. So the first cone gets poured in, and it's going to fill it exactly 1/3 of the way. And then as the second cone gets poured into the cylinder, it goes 2/3 of the way. Now, when I first looked at it, it almost looks like it was a little too high, and that when the third cone gets poured into the cylinder, that would overflow. But every last drop gets poured in there, and everything stays in the cylinder right to the very top, showing that 3 cones equals 1 cylinder, which is why the formula is the same, just divided by 3. Let's take a look at the types of problems that you're going to see with this. We're going to start off with the cylinder, and here is a cylindrical water tank, not nearly as large as the one that we saw up by Flagpole Hill, but we have a cylinder, and just like this whole section has been, we're dealing with formulas, which are just algebraic expressions that we're going to substitute numbers in for the variables and just follow order of operations, which is why we looked at algebraic expressions earlier, and then also followed that with areas of bases, which in this case, our base is a circle, which is why we're dealing with pi r squared for the area of the base. So for the area of a circle, we're looking at pi r squared. R represents the radius, and that's exactly what they give us. All right, remember, if they gave us the diameter the whole way across, we have to cut that in half, but they gave us the radius here, so we're going to substitute 6 in for r, and it also says let's go ahead and use 3.14 for pi. So we have pi r squared, we're going to put 3.14 in for pi. We are going to substitute 6 in for that r, and then we can't forget about our height. Our height is 15. So those are the substitutions that we make. And then according to order of operations, all right, looking at parentheses, exponents, multiplication and division, and then addition and subtraction. There are no parentheses that we need to worry about, but there is an exponent with that squared. So we need to make sure that we do that exponent first. So 6 squared is 36, and then everything is multiplication. So we can go ahead and take 3.14 times 36 times 15, and we're going to get 1,695.6. All right, so that's our answer for the volume. Now, the other thing we have to remember is volume talks about how many cubic units can we fit inside of that. So this is cubic feet that we're dealing with. So it's 1,695.6 cubic feet. So make sure that you're using that as your units when you are putting your answer in. Now, here is another cylinder problem, and I absolutely love this problem for a number of reasons. So we're going to take a look at why. So same idea. We are looking at using the formula volume, pi r squared times h, but a couple things to keep in mind here. First of all, we have to make sure that we are substituting the correct numbers. And this is why I like this one, because if you get this problem right, it really means that you understand what these variables mean. So remember, the r stands for the radius, and the radius is halfway across the circle. So basically from the center to the edge out. And if we look at this cylinder, they give us the diameter. So we have to cut that in half. So we know that r is going to actually be 3 in this case. Now the other thing to remember is height is not always going from the bottom to the top. All right, so the height is not 6 here. All right, so we have to make sure that we don't consider that. All right, so what we have to realize is that the height is actually the distance between the bases, so the two circles here. So the height is going to be 31 in this case. So that's why I like this problem, because there's actually two things that you really have to understand in order to get this correct. And then once we do that, everything is the same. We have our formula, and we just need to make sure that we substitute the appropriate numbers in for the variable. So we know we're using 3.14 for pi. Now we know that we are using 3 for r, for the radius, and the height is 31. And just like the last one, we're going to make sure that we do the exponents first, because that is what we do first in the order of operations here. So we have 3.14 times 9 times 31, and that gives us 876.06, and we're not going to forget that this is cubic feet. Now let's finish up with a volume of a cone problem. So remember, the formula is nearly identical. The only difference is once we do the pi r squared h, so kind of like finding the volume of the cylinder, we're going to go ahead and divide by 3 here. So we have this cylinder now, where we're looking for what are we going to put in for r. They give us the diameter. So as the diameter is 10, r, we cut that in half, so the radius is 5. So make sure that you understand what the variables mean and the parts of the circle. And then h, going from the base, so the circle, up to the tip of the cone, h is going to be 12. So this is what we're going to be substituting in for the variables in this formula, as well as 3.14 for pi. So volume, we've got 3.14 times 5 squared times 12, all divided by 3. Now, here's kind of a neat little trick here that we can use sometimes. 3 and 12 can simplify quite easily. All right, so if that's the case, if you get something divisible by 3, either after you find the square, so the 5 squared, or the height, you can go ahead and simplify that. Now, that being said, it's probably best to go ahead and do the exponent first. All right, I don't want you to think that before you square that you can simplify, because that's part of division. So I think it's important. Let's do the exponent first and then see if we can simplify, because sometimes we can simplify the 3 with whatever the radius is squared as well. But let's backtrack here. Now let's go ahead and simplify the 12 and the 3, and that becomes 4. So we've got 3.14 times 25 and then times 4. We really don't even need a calculator for this now that I look at it. So 25 times 4, that's simple. There are 4 quarters in a dollar, so that's 100. 3.14 times 100. And multiplying by 100 just moves that decimal over 2 places, so it's 314. And what we can't forget, we're still dealing with volume, so it's 314 centimeters cubed. All right. So this assignment, we're looking at volume of cylinders and volumes of cones, and they're very, very similar, nearly identical, except when you're doing the cone, you just have to remember to divide by 3. Speaking of your assignment, for Monday and Tuesday, your assignment is called Volume of Cylinders and Cones. It's on alex.com. It's 10 questions, so it's worth 10 points. And don't forget, you can always Zoom for help during your class time or during my office hours. Also, I adjusted the settings in Alex so you are not locked in to doing one assignment and then going in order. So I changed it so you can do whichever assignment you are on. So I know a lot of people are getting hung up on advanced Pythagorean theorem. So if you want to skip that for now and work on another one, you may, and then go back to it. And remember, I'm available to help on any assignment. You can email me, we can set up a Zoom time, or obviously just come to the scheduled Zoom sessions for help, and I can help you, like I said, with anything. Good luck.